Howdy everyone, Mr. Causy here again with another chemistry lesson, and this time we're going to talk about periodic trends. And the importance of periodic trends is to help us make decisions with bonding and chemical reactions. And especially I want you to pay attention to electronegativity. So let's get started. Periodic trends, there's four main periodic trends: electron affinity, atomic radii, ionization energy, and electronegativity. Now, electron affinity, we're not going to pay a whole lot of attention to. Atomic radii, we want to look at and get an idea how the radii affects the volume of the atoms. What was really important is looking at ionization energy and electronegativity. And electronegativity is something we're going to use in depth in helping us make decisions about chemical bonding. So we want to definitely learn electronegativity. Electron affinity is the energy released when adding an electron to an atom. Now, when we add an electron to an atom, energy is going to be released when that happens. Atomic radii is 1/2 the distance between the nuclei of two atoms of the same element. So you have two atoms of the same element right next to each other, and we measure the distance between the two nuclei. Cut that in half, and that's the distance of the radius of one atom of that element. And this can be useful in determining the sizes. The trend on atomic radii, it decreases as you go left to right, and it decreases as you go up. Now, what you want to remember is the reason it decreases as you go across is that the number of protons is increasing. And as the protons increase, the electrons increase, and so there's greater attraction. So the big part about atomic radii as it goes left to right, they're all in the same energy levels at this point, but there's more electrons and more protons as you go across, a greater attraction, so it kind of pulls in and makes the atom a little bit smaller. And of course, it decreases as we go from up or increases as we go down, because that's the energy levels. And of course, neon's going to be bigger than helium. It's in the second energy level. And of course, argon's going to be bigger than neon because it's in a higher energy level. So as you increase in energy levels in the columns or families, you get larger. And as you go left to right in the periods, you get smaller. So you want to pay attention to that, and it gives you an idea of the sizes of the atoms. Ionization energy. Now we want to pay attention to ionization energy because it helps us think about reactivity and things of that nature. The minimum amount of energy required to remove an electron from an atom is ionization energy. Ionization energy increases as you go left to right, and it increases as you go up. And now remember, think about this. Ionization energy is the minimum energy required to remove an electron. Well, all of the noble gases, if you remember from the octet rule, they have their octet. They have their filled outer shell. Their valence electrons are all there. They don't want to give or receive electrons. They don't want to receive them or give them. So if they don't want to receive or give electrons, think about it. Is it going to be easy to remove an electron? No, it's not. It's not going to be easy at all. It's going to cost quite a bit of energy to try and take something away from a noble gas. And the same thing for the halogens. Fluorine wants its electrons. It wants another electron. Why would it give one up? If you're going to take an electron away from fluorine, it's going to cost you, and it's going to cost you in energy. However, on the flip side, look at sodium. Sodium has one valence electron, and it wants to give it away anyway. So if it wants to give it away, is it going to cost a lot of energy to take it away? No, it's not going to cost a lot of energy to take it away. So your metals are willing to give up their electrons. They're willing to let it go. So if they're willing to let their electrons go, it's not going to cost a lot of energy. So they have low ionization energies. So your metals tend to have low ionization energies, and your nonmetals tend to have high ionization energies. And that's an important fact that we want to remember. Now, let's look at the next thing, electronegativity. Now, electronegativity is the measure of an atom's ability to attract electrons. Pay attention to that, attract electrons. Which means then it's going to increase as you go across and increase as you go up, because fluorine wants electrons. And so it's going to attract electrons. As a matter of fact, fluorine is the highest electronegative element there is. Now look at sodium. Sodium wants to give an electron. If it wants to give an electron, is it attracting? No, it's not going to attract. Calcium, it wants to give 2 electrons. Is it going to attract electrons? No, it's not. They're going to have low electronegativities. But your nonmetals and things like halogens, they want an electron. Oxygen in the chalcogens wants 2 electrons. It's not going to give up electrons, at least not easily. It's going to attract electrons. So remember, electronegativity has to do with the ability to attract electrons. And that brings up an interesting question about the noble gases. Think about this. The noble gases, they have all their valence electrons. They're not going to attract electrons. They're not going to give away electrons. So in essence, the noble gases' electronegativity is 0. And fluorine's is 4. That's the highest electronegativity possible, at least on the Linus-Pauling scale. And that's a scale we usually use, especially at the high school level. We use the Linus-Pauling scale, and he measured everything from 0 to 4, 0 being the noble gases, and then things like the metals range somewhere between 1 and 2 and 2.5, and then you've got your nonmetals, which are usually around 3. Now, electronegativity is going to be so important for us to understand, because it's electronegativity that we can use to understand why certain things bond the way they do, whether something is ionic or covalent. The electronegativity values help us make decisions. Now, I'm not expecting you to memorize all the electronegativities. What you need to do is understand the trend. Elements go across the table, electronegativity increases, and as we go up the table, electronegativity increases. And so this kind of makes francium one of the lowest electronegativities, and fluorine one of the highest. And of course, the noble gases are 0 electronegativity. Keep that in mind. Now, let's think about it. What is the electronegativity of the noble gases? And you're probably thinking 0. And you'd be right. Why? Well, because they don't want any electrons, remember? They have filled octets. Let's look at another thing about it. Which element has the highest electronegativity? And of course, you would be thinking fluorine. Which element has the lowest electronegativity? Now, that's excluding the noble gases, and that would be francium. Which has the highest electronegativity here? Now, when you look at those, which one do you think would have the highest electronegativity? I look at those, and it's probably going to be oxygen. As a matter of fact, I probably forgot to tell you this, but fluorine is the number 1, oxygen is the number 2 highest, and chlorine is the number 3 highest in electronegativity. And so you might just want to memorize those 3 in their order. It'll help you out later. So which one here has the lowest electronegativity? You think about that there, and it should be neon. Yeah, the lowest electronegativity, if you include the noble gases. If you didn't include the noble gases, which are 0, then we'd probably have to say sodium. Which has the lowest ionization energy? It should be sodium. Which has the highest ionization energy? Well, it would be the noble gas, so that would be neon, and it's neon. Which atom or ion is smaller? Magnesium. That's right. Now notice, they're in the same energy level, and magnesium is a little bit more to the right, so it's going to be a little bit smaller. It has a few more electrons and protons, greater attraction, and so it's going to be a little bit smaller than sodium. Which atom or ion is smaller? In this case, bromine is going to be the larger one. It's in a higher energy level. So I'll bet it's chlorine, and it is. It's chlorine. In this one here, which atom or ion is smaller? Well, think about it. We have aluminum, and we have aluminum 3+. It's lost 3 electrons. And so I would say that probably causing it to shrink a bit, and we'd say the aluminum ion there is going to be smaller than the atom. All right, if you have any questions, remember send an email to Mr. Causy at mrcausy.com. And don't forget to check out www.mrcausy.com. PowerPoint videos and much, much more. And oh yeah, don't forget to subscribe to my YouTube channel to pick up on some of these videos and know when the latest one has come out. I have many more videos to come. All right, well, happy ions.